Hello, welcome back. In this session we are going to see about the history table and what is the use of the history table. So I prepared the statement to save some time. So this is the history table creation statement, and there is nothing new compared to the column store table creation statement, but the only extra keyword is history. Okay, and another important thing you need to remember is the table should have primary key. The primary key is mandatory in case of history table. Let's run this statement and see. Okay, history table is created. Now to understand the difference between the regular column store table and history table, let's use one of the table, the system table, to understand this. So if I run this statement, so okay, instead of going with those fields, let's go with select star from. So if I run this, you see all the tables in my T4H schema, right? And here there is a column called session type. In the session type you see the history. All other tables are with the session type simple, but the only history table is having the session type history. Why that is so important? So let's see. Okay, so let's make it simple, the required columns. Okay, so now we have all tables and everything, all tables are column store table, but the only this table is having the session type history. So that's why that is a history table. Based on that result we can say this is a history table. Okay, so because of the different session type, so the history table works differently. How? So if you want to understand the history table behavior, first we need to make the, so for example here if you go to properties, properties, and auto commit on, right? So by default auto commit is on, and you need to make it off for the history table to work. Okay, the connection is changed, results are closed. Okay, let's insert some records into this. Insert into salary underscore tracker values. My simple ID and name is, I'll use Mr. A. I'll say 5,000 his salary. I'm pressing F8 to execute the statement. I'll copy and create one more record for Mr. B, and his ID is 2, and the salary also 6,000. Okay, so we inserted 2 records, same as the regular one. Since we made the auto commit off, we have to exclusively run the commit statement and also delta merge statement. So you know what is delta merge, right? So update salary underscore tracker table merge delta index. This is the standard delta merge statement you can use on any. So if the auto commit is on, then this is not required, these 2 statements automatically commits. But since the history table to work properly, we have to make auto commit off. Now if I run the select star from, I see Mr. A, Mr. B having 5,000, 6,000. It's like a regular column table, right? But history table comes with 2 extra fields. which are hidden fields, I say. Those are valid from valid to. So these are the two fields comes in the history table. So you see the valid from, valid to. So valid from, we have some number here, but valid to is blank. Okay. And there is another special statement we use in history table is request flags is equal to all rows. So that for now there is no change with that statement. It's same as the select star valid from and valid to. And remember one more thing. So if you say valid from in the uppercase, valid from, it will not identify. Okay, so it should be lowercase. Okay, so what the next question is, what are these numbers in the valid from, right? So those are actually the commit IDs. Each commit statement in SAP HANA is marked internally with a commit ID. And to understand better on the commit IDs, let's explore one more table. You are getting more tables in this statement, right? So here one is the sys.tables, and now we are going to see another table, m_transactions. Okay, yes, it's missing. So if you see this table, this is the transaction table, and it logs each and everything, like which host, which port, and connection ID, everything. So we are more interested on the last commit ID. Okay, so let's make this statement something like this. Select last commit ID from m_connections, where connection is ID is equal to current connection. So current connection is my session connection, so which is 1740142. And if you see here 1740142, so that is the last commit ID into the table. Okay, as of now everything looks smooth and nothing very exciting about the history table, right? So now let's see the magic by updating one record here. Update salary tracker, set, we'll change the salary value from 5,000 to 5,500, where ID is equal to 1. This is regular update statement. Good. Now since we don't have this auto commit on, we have to run this statement once again, commit and delta merge. Good. Now let's see the data, how this changed. Interesting, right? So these are the previous old records, and this is a new these two are the old records, and this is a new record. So now see, if the commit ID 1740142 was our old valid from values, and now the record ID number 1 got the valid 2 value 805, and again new record created with valid from. So what happens is, whenever the first time when you insert a new record, it comes with the valid from, and valid 2 will be null. And when you update that particular record, automatically valid 2 will become the latest commit ID, and the same commit ID goes to the valid from for the new record. So that's how the commit IDs manages this history table. And when we go to the next session on the time travel queries, you will see the benefit of this commit IDs changing from one value to another value, why it is important. Okay, for now you just understand, when you insert new record, commit IDs valid from commit IDs will be there, but valid to is null. But when you update any of the particular record, automatically valid to will update with the latest commit ID, and the same commit ID will continue as a valid from for the next that updated record. So now the old one 5000, the new one 5500. Okay, so that's all for this session. See you in the next session. Until then, happy learning. Bye.